This is Mr. Herman. Before we begin with proofs, we're going to review some proof properties that we'll be using. Now, some of these, actually all of these, you've seen before, but we want to make sure that you have a review of what they are, what they look like, before you begin writing proofs. It's important to recognize these properties because they will be crucial in writing our proofs later on in this unit. So, the properties that we're going to review briefly are the reflexive property, alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and vertical angles are congruent. All right. Now, we're going to look first at the reflexive property. Now, the reflexive property is the property that we often miss because it seems too obvious. Okay, what the reflexive property tells us is that a side or angle is congruent to itself. Now you might be saying, Mr. Herman, Mr. Gibson, why are we using the reflexive property? It seems obvious. Well, it is obvious, but that's part of the reason why we need to have it. If we don't have it, then we have not explicitly stated in our proof that a certain pair of sides or certain pair of angles is congruent. If we don't do that, then we don't actually have congruent triangles or similar triangles or whatever we're trying to prove. Okay, so that's why it's important. Now, what that means is that if we take a look at this triangle here, we've got A, B, C, D, and E. Okay, so the reflexive property would say we're looking for an angle or side that's congruent to itself. A good hint here is look for a part of a triangle that is in two triangles. Okay, so hint, look for a part of a triangle. Okay, look for a part of a triangle that could be in multiple triangles. Okay, so we're going to do just that when we look at our figure right here. Okay, so we've got our big triangle here. Now I see this big triangle ACE, and I see little triangle BCD. Now, if we think about which part is in both triangles, that's going to be angle C. It's in the small triangle. It's in the big triangle. Okay, so that means that we have to state that angle C is congruent to angle C by the reflexive property. Okay, now it might seem obvious, and it is obvious that those two angles are congruent because it's the same angle, but we still have to state that. Now, let's look at another problem where we have a quadrilateral split in half by a line. So once again, let's use our hint up here. Look for a part of a triangle that could be in multiple triangles. Okay, so if I'm looking here, I've got triangle ABD and triangle CBD, and I think to myself, oh, BD is in both triangles, so it's got to be congruent to itself. So BD is congruent to BD. Okay, now we can't just leave it at that. We have to say why by the reflexive property. Okay, now it seems obvious because it makes sense that it's true, but we still have to make the statement. This is where I see so many people miss points on. Okay, we don't make that statement, so our final proof statement can't be true because we never said that those two parts are congruent. All right, now let's move on to our congruent angles. We're going to do all four of these ones in the same section because they're very similar to each other. Our angle congruency theorems. Okay, so vertical angles. Vertical angles are across from each other at intersecting lines. Okay. Our alternate interior angles, they are inside the parallel lines on opposite sides of the transversal. Okay, now we are throwing it back here a bit by using fancy words of parallel lines and transversal. I'm going to dip down for a second just to look at our picture. This is what we're going to look at in a second. Okay, so I think that this should be familiar to us. We have a two parallel lines noted by our arrows here. That transversal is cutting through. And then we've got 1, 2, 3, 4, 5, 6, 7, 8 angles that we're going to make a chart in a minute. All right, alternate exterior angles, those are outside the parallel lines, hence the exterior, on the opposite sides of the transversal. Okay. Outside the parallel lines on the opposite sides of the transversal. And our last pair is our corresponding angles. They are located in the same position, but at a different intersection point. Now, if any of these definitions are confusing, we'll put some visuals to this in a minute to help match up with these definitions that we have. Now, let's go ahead and look here. We've got our vertical angles are congruent. So vertical angles are across from each other. That would be 1 and 4. So we have angle 1 congruent to angle 4. We have angle 2 congruent to angle 3. They're across from each other. Angle 5. Oh, whoops. Angle 5 is congruent to angle 8. They're across from each other. Angle 6 congruent to angle 7. They're across from each other. Alternate interior angles. I kind of jumped the gun here. If we've got 5, it's inside the parallel lines on this side of the transversal. We're looking for across the transversal. So angle 5 is congruent to angle 4. Angle 3 is congruent to angle 6. That's all inside. Alternate exterior, we have angle 7 congruent to angle 2. Angle 8 congruent to angle 1. And then our corresponding angles, we've got angle 1 is the top left corner. Angle 5 is top left corner. So those are going to be congruent. So angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. Both bottom left. And then angle 4 and angle 8 are both bottom right. Angle 4 is congruent to angle 8. Okay. Now, you've got a few questions to answer regarding these theorems.